இதுவே 9 பேர்னா 4 எங்க டீம்லயே 9 பேர் தான். 4 ஆப்சென்ட் வரல 4 பேர். அதனால நாங்க டீம்ல ஆனா நாங்க ஆரஞ்சு டீம்ல 9 பேர். அவங்கள நாங்க ஜெயிச்சோம்.
Students, good evening. How are you guys? Practiced any numericals over parabola, circle, and ellipse? Anyone having any doubts? Before moving to hyperbola, anyone having any doubt? Students, please respond. Guys, Harshida, Raghav, students. Today we are going to discuss the last part of the conic sections, hyperbola. See, from the section point of view, what is when hyperbola will be formed? Anyone can able to recollect at what situation hyperbola is formed? Anyone can remember hyperbola? When hyperbola will be formed? Suppose if I am taking double nap cone, this is the axis. What is the condition to generate hyperbola? Anyone can answer, please respond. Students, please respond. What is the condition to generate hyperbola? How to cut? If I'm taking a plane like this, at what angle? What is the minimum and maximum angle? Minimum and maximum angle to cut to form hyperbola. At least now we can able to give the answer. What is the angle I have to maintain?
Sir, the angle should be less than the angle of that cone.
Zero less
in order to make a hyperbola.
Beta less than alpha, where alpha is the semi-vertex angle. Beta is the angle between axis of the cone and cutting plane. So this is conic section point of view. We will define like this. We will get a diagram like this. Here one diagram, here we will get. Same as ellipse. These are the two curves, two symmetric curves about y-axis or x-axis, is known as hyperbola. This is general discussion. Same as ellipse and parabola and circle, from plane geometry point of view, we are having a definition. Another definition of hyperbola. Anyone can define the ellipse definition from the plane geometry point of view? Students, anyone can give the definition of ellipse? What is the definition of ellipse? What is the definition of ellipse? Students, I'm waiting for you people. From the plane geometry point of view, what is the definition of ellipse?
Sir, locus of points from two fixed points is that the distance from the two fixed points should be a constant.
Locus of points, collection of all the points in such a way, from a point p x comma y, the sum of the distances between a point to two fixed points, Pf1 plus Pf2 is constant, which is satisfying this condition. If I am collecting all the points, whatever the curve I am getting, that is ellipse. In the same way, Pf1 minus Pf2 is constant. What are all the points I am getting? That is hyperbola. Now anyone can define with respect to this equation, what is the definition of hyperbola, students? Students, please.
So the locus of points from two fixed points such that the difference of difference of the distance from the two fixed points is a constant.
Correct. The locus of points in a plane, locus of points in a plane, because it is formed by a plane in such a way, the difference of whose distances from two fixed points in the same plane is a constant. So with respect to this, I will get a diagram like this. If I'm tracing all the points like that, I'm getting two curves, two symmetric curves like this, two distinct symmetric curves like this. So according to this, if I'm taking two fixed points, this is F1, this is F2. I'm taking randomly one point, a few points I'm marking here. P1, P2, P3, P4. I'm taking P1. I joined P1 to PF1, P1 to PF2. What is the definition says? Locus of the points in a plane, the differences whose distance from two fixed points in the same plane is a constant. I can say P1 F2 minus P1 F1 is equal to, I'm taking P2 F2, P2 F1 minus P2 F2. From this diagram, I can say P2 F2 is bigger, P2 F1. So instead of the, if I'm taking modulus, whatever the order it is, it doesn't matter. P3 F1 minus P4. P3 F1 minus P3 F2 is equal to P4 F1 minus P4 F2. Like that, how many points I can able to collect? Collection of all these points, the differences from a point to two fixed points is constant. The difference of the two distance, the difference from a point to two fixed points is always constant. So the curve traced by this is known as hyperbola. It's a two different curves. It's symmetric about one particular line based on type of hyperbola. And these are the 2 points. The 2 fixed points is known as foci, and the curve meeting the axis, the line passing through foci, is called major axis. And symmetric about a line, that line is called minor axis. The point of intersection of major axis and minor axis is known as center. Here we won't call actually major axis and minor axis. We will call as the conjugate axis. And this is called transverse axis. And the curve meeting the transverse axis is known as vertex, like ellipse, 2 vertex, center, focus. And if I am drawing 2 lines in such a way where it is meeting, these, there will be only one set of line will be available. It looks like tangents to the hyperbola. The tangent, it will meet the hyperbola at infinity. This is called asymptotes. These 2 lines, this pair of 2 lines is called asymptotes. We don't discuss much about the asymptotes. But to explain length of the major axis, length of the minor axis, we require this concept of asymptotes. We will see in the separate diagram about the length of the, instead of length of minor axis and major axis. Why I am mentioning major axis and minor axis? It will be easy to solve the questions. If I am comparing major axis to transverse axis, minor axis to conjugate axis, it will be easy. Yes, now we are going to solve how to solve the equation of hyperbola. Same as ellipse. Anyone can recollect how to solve the equation of standard equation of hyperbola? Equation of hyperbola. Equation of hyperbola. Who is going to discuss? How we can discuss the equation of hyperbola? So me later thought this clear. Students, I will give certain inputs. Anyone can give the idea how to solve equation of hyperbola. Strangely, it will look like equation of ellipse with a small sign different. This is F1. This is F2. The distance between focus, as see, names we are not going to change. The distance between 2 focus is C, 2C. Means from the center of the hyperbola is C, and vertex distance also A we will consider. Generally in ellipse we are considering this is called major axis, but what about minor axis? This is very much important. The distance between 2 focus is represented by 2C. The distance between 2 vertices is represented with 2A. What is another term? From that only we are giving asymptotes, concept of asymptote. Asymptotes are like tangents to hyperbola at infinity. It will meet the hyperbola at infinity. There will be only one set of pair of linear equations will be, pair of straight lines will be available in such a way. These are called asymptotes. To understand the length of the conjugate axis, at vertex you draw a vertical, and where it is meeting the asymptotes, You can see I will draw in red color. That is the length of 2b. This length is 2b. This is a given data. With the help of this, I have to calculate. This is origin. From here, this is minus c comma 0. This is plus c comma 0. And this is plus a comma 0. Minus a comma 0. And this is 0 comma plus b. 0 comma minus b. These are the points I am having. First step, relation between A, B, C. Anyone can give the idea how to give the relation between A, B, C here? Relation between A, B, C. How we can give the relation between A, B, C here? I'm writing the relation between A, B, C is equal to B square is equal, sorry, C square is equal to A square plus B square. How? Who is going to explain how to derive this one? Anyone? Students, please. How we can define this value, this length? C square is equal to A square plus B square. Students, please respond. Guys, will you able to hear me?
Yes, sir.
Yeah, how we can prove this one?
Sir, could you repeat what P is?
I'm asking C square, relation between ABC is A square plus B square is equal to C square. How we can prove? How we can prove? Anyone? Guys, please respond. It won't be available in textbook. Any standard textbook, it won't be. Yeah. So we will take this relation, we will proceed. In next class, just try to explore yourself. I will explain in next class how this relation we got. It's not like ellipse. It was not so easy to prove like ellipse. Now, we are saying the difference between, suppose if I'm taking any point P, if I'm taking Pf1, Pf1 minus Pf2 is constant. How to calculate this constant value? By taking this diagram. I'm taking a point P on the ellipse. I'm calculating P1 F1, sorry, P1 F2 minus P1 F1 value. So I'm assuming a point A exactly of one vertex. So this A is also point on the hyperbola, or B is also a point on the hyperbola. If I'm taking BF1 minus BF2 will be equal to AF2 minus AF1, where A is a point and F1, F2 are the fixed points. The difference between AF2 minus AF1 must be equal to the difference between BF1 minus BF2 should be constant. We are going to calculate this constant. I am adding both sides. Sorry guys. This AF1 I am bringing this side. This BF2 I am taking this side. BF1 plus AF1 is equal to BF2 plus AF2. How we can write this one? BF1 means from here to here. See here. This is BF1. And BF2 is this. So this can be written as AB plus, so this is B, this is A, F1, F2. So from here to here can be written as BF1 can be written as BA plus AF1, BA plus AF1 plus BF2. Sorry guys, BF1 can be written as BA plus AF1 plus AF1 is equal to same as BF2. This is BF2 and AF2. This is AF2. AF2 can be written as BF2 I am keeping as BF2. AF2 can be written as AB plus BF2. So AB can cancel. This is 2 times AF1 will be equal to 2 times BF2. 2 to cancel. AF1 is equal to BF2. AF1, that means the distance from A to F1 is equal to distance from B to F2. So with the help of this, if I am taking BF1 minus BF2 is equal to BA plus AF1. See, BA plus AF1 minus BF2. From here, this one cancel, which is giving BA. The value of BA is 2A. So what is this meaning? The constant is what? This constant is length of transverse axis. Of this derivation, we can define hyperbola in a different way also. Length of transverse axis. Is it clear, students? What I am trying to conclude with this discussion?
Sir.
Yes.
Sir, but we can directly say, right, A is like in all the cases, parabola, circle also, A is the distance from the origin.
Correct.
Sir,
A is
so
the
here,
distance from the origin to the vertex, not to the focus here. See, A is a distance from here to here only. This is A. From here to here, it is C. But we don't know whether AF1 is equal to BF2. That we don't know. That's the reason this proof we are doing. Usually we know the focal length is constant. The focal length should be same. But we don't know now. How we can say the focal length must be same for the both the curves here. In
So,
case
but
of
we are also assuming, we are also assuming this is on a axis, right?
which one?
So the hyperbola is on the axis, so that this becomes a transverse axis. So since axis is anyways a straight line, so wouldn't that be
Even though
same?
since axis is a straight line, but we can't say distance is compulsory, it is same now. We can't say AF1 is equal to BF2. We can't say always. But in hyperbola, we have proved. Suppose if in case of next year, we'll get a light. Already we done in grade 10. If you are taking two different radii concave lenses, you will get different focal length for the same lens. Suppose if I am taking one lens, and if I am taking one more curvature lens, you will get the different focal length. This is F1 and this is F2, but it is not part of the syllabus. See, to understand whether it is having same focal length for both the curves, this is a proof we are doing. We can't say directly here. Axis is by definition we are defining the axis. The line joining of F1 and F2 is axis. Where it is meeting the curves is known as vertices. But we can't say vertices, the distance between vertex and the focus, both the curves is same or not. But we proved it is same here. Understood what I am trying to say?
Yes, sir.
Yes, we are trying to say it is same. The focal length for both the curves is same. Because it is two different curves. There is no joining here. There is no joining here. And it is symmetric about one particular axis. How I can say that it is symmetric about particular axis? After this, if I want to prove it is symmetric about particular axis, there is another way of proving all the things. But we are proving only a basic thing. The difference is a fixed distance. That constant is length of the transverse axis. Next one is eccentricity. Same like ellipse, here eccentricity is ratio of C by A. So here C is greater than A. So your eccentricity is greater than 1 for hyperbola. Eccentricity is less than 1 for ellipse. Eccentricity is equal to 1 for parabola, but we won't discuss about parabola. Even lattice rectum also, if you are thinking why we have to discuss lattice rectum and what is one more part? Sorry, completely forget. We won't discuss for ellipse and all, but parabola will discuss. Directrix. Directrix is also having some significance. How we can say this is only the directrix? Why is there any possibility why directrix is not available for ellipse and hyperbola? Yes, directrix is available for ellipse and hyperbola also, but here we won't discuss. For our scope of syllabus, we are not going to discuss about the directrix of the ellipse and hyperbola. Might be if you are doing for entrances, we will discuss. Some other boards we are having the directrix for hyperbola and ellipse also in part of the syllabus, but for CBSE it is not part of our syllabus. Yeah, so now we are discussing standard equation of hyperbola. With the help of all these things, how we can approach, how to solve the equation of hyperbola. Standard equation of hyperbola. I will give only the diagram. Anyone can try. Same as ellipse. Take the definition and you can start. This is minus c comma 0, minus a comma 0, 0 comma 0, a comma 0, c comma 0. If the transverse axis y-axis, my hyperbola looks like this. For convenience, here also I am taking this is 0 comma minus c. This is 0 comma minus a, 0 comma a, 0 comma c. How we can discuss? What is the condition, guys? Suppose if I am taking a point P here, this is F1, this is F2, my P is x comma y. These are the dotted lines. Pf1 minus Pf2 is how much? Pf1 minus Pf2 is how much? From the previous discussion, it's a constant.
2a.
What is the constant? 2a. Understand why that derivation we done here?
Yes, sir.
So Pf1 minus Pf2 is equal to 2a. Pf1 is equal to 2a plus Pf2. Square on both sides. Pf1 whole square is equal to 2a plus Pf2 whole square. So apply the distance formula and do it. I'm giving few minutes time, please.
Sir, could you show the diagram?
Yeah. Please. This is Pf1 square is equal to 4a square plus Pf2 square plus 4a Pf2. 2 into 2a into Pf2. 2 into 2, 4a Pf2.
Sir.
Yes.
Sir, it becomes x square plus c square plus 2xc.
X square plus.
Sir, x square, like I'm telling after solving, sir, like x square plus c square plus 2xc.
This is x plus c whole square plus
y square
square
over root whole square.
4a square plus x minus c whole square.
Yes, sir.
Plus y square, correct?
Yes, sir. Sir, so we can
Plus
cancel
4a root of x minus c whole square plus y square. Y square is cancelled, correct?
Sir, x square and c square also we can cancel, sir.
From here, x plus c whole square minus x minus c whole square minus 4a square is equal to 4a under the root x minus c whole square plus y square. So this a plus b whole square minus a minus b whole square is 4xc, correct? Confusion? Any confusion? No, clear? So this is x minus c whole square plus y square. 4 cancel. If I'm taking square on both sides, what we will get? Before square, this can be written as xc by a minus this 4 cancel. A. Xc by a minus a is equal to x minus c whole square plus y square under the root. Now if I'm taking square on both sides, x square c square by a square plus a square minus 2xc by a into a is equal to x minus c whole square plus y square. This a cancel. Wherever you are having c square, make it as a square plus b square and do it. Let me know what is final answer you are getting. What is your final answer? X square into a square by a square plus x square into b square by a square plus a square is equal to x square plus c square minus this 2xc. This is minus 2xc here, minus 2xc plus y square. So minus 2xc cancel. Instead of c square, I am writing as a square plus b square. A square and a square is cancelled. What I will get? X square is a square cancel. X square plus x square b square by a square is equal to x square plus b square plus y square. Again x square and x square cancel. If I am dividing everything with b square, x square b square by a square b square is equal to 1 plus y square by b square. So again b square cancel. Finally I am getting x square by a square minus y square by b square is equal to 1. This is the simplest form of the equation of hyperbola.
Sir.
Yes.
Sir, after cancelling a square and minus 2xc, like before taking LCM.
Which step? I will mark the step. Can you? This one? This one?
1 second, sir.
See, calculation is your wish. You can do any approach. You can approach in any way. But this is my approach. Because in textbook, they didn't give any calculation. For other simplification, they wrote the final equation. That's it. Will explain?
No, sir. I don't know. I'm getting different answers, sir. Could you explain again, please?
I will erase and I will discuss again. This is a little bit, because based on some schools, they will ask these derivations. That's what I observed. Is it clear up to here? Or this also I can? Yeah. If up to here it is clear?
Yes, sir. Yes, sir.
So I'm taking square on both sides. What I will get if I'm doing square on both sides? Xc by a minus a whole square. And if this side, x minus c whole square plus y square.
Sir, x square c square upon a square plus a square minus 2xc.
Minus 2xc.
X square plus c square minus 2xc plus y square. So minus 2xc gets cancelled.
Next, since c square is equal to a square plus b square, substitute x square into a square plus b square divided by a square, correct?
Yes, sir. Plus a square equals
square is equal to x square
plus a square plus b square plus y square. So a square also cancel over there.
This I am splitting into two fractions. X square a square by a square plus x square b square by a square is equal to x square plus b square plus y square. A square cancel.
Yes, sir.
So it will become x square plus x square b square by a square is equal to x square plus b square plus y square. X square cancel. Agree?
Yes, sir.
Finally, x square b square by a square is equal to b square plus y square. Divide both sides with b square. What I will get? X square by a square.
Square upon a square equals 1 plus y square upon b square.
If I'm taking all variables on one side,
Okay, sir. Got the answer, sir.
same as if I'm doing for if y-axis is my transverse axis, if y-axis is my transverse axis, how we will get?
So
Y
x
axis
square
will-
upon b square minus y square upon a square equals 1.
Correct. Simple. X square upon
Sir, actually, no, sir. Y square upon a square minus x square upon b square equals 1.
correct. This is the x-axis as transverse. This is y-axis as the transverse. Is it clear, students?
Yes, sir.
Lattice rectum, same as ellipse. What is the definition of the lattice rectum?
Sir, a perpendicular line from
A line
the
segment.
focus to the
Line segment perpendicular to, instead of major axis, transverse axis through any one of the foci and whose endpoints lies on hyperbola. If this is an hyperbola, this is the focus F2, this is F1, this is my lattice rectum. And I'm saying length of the lattice rectum is, if the x-axis is transverse axis, the length of the lattice rectum is 2b square by a. Even y-axis also 2b square by a. Only the thing is, denominators of the x square, y squares will be little different there. Anyone can prove this one, how it is 2b square by a. It is not there. These two proofs I am giving as the self-learning. You try. Otherwise, we will discuss at the end of the conic sections. Now,
sir, can I try?
yes, please. If you know, please try.
Sir, let the point be x comma y. Sir, where it intersects the hyperbola.
This point is
X comma y, sir.
x comma y.
Sir, so we know the
Equation is
equation.
x square by a square minus y square by b square is equal to 1, correct?
Yes, sir.
This is 0, 0. This
Sir,
distance
so
is
C
2a.
becomes x becomes C and y becomes I don't know, B, I think.
Sorry, guys. One person rituals is going on. This is a village. These people will do like this if they're having too much of disturbance. If I'm taking this point, this
Sir,
is
so the
lying on-
x variable becomes c, sir.
how we will know?
Sir, because that's a focus, right? That's perpendicular. That's all.
Correct. Superb. This is c comma 0. So this is c comma y. If I am substituting c square by a square minus y square by b square is equal to 1. So y square by b square is equal to how much?
Sir, c square upon e square minus 1. Yes, sir.
So y square is equal to how much here?
Sir, y square equals c square b square upon a square minus b square.
What is this value?
Sir, that is b square, sir. Sir, shouldn't it be plus, sir?
Y plus O plus. So y is equal to b
Sir,
square by a.
Sir, it should be c square b square upon a square minus b square.
I
Sir,
didn't get-
y square after taking b square that side, y square equals c square b square upon a square minus b square.
No, like this. Look into this properly.
Sir, it's correct only, sir. C square b square upon a square and then minus b square as a separate term.
You're multiplying with this one inside.
Yes, sir.
Okay. Anyway, finally, I'm getting y is equal to b square by a. So the total length is 2y, correct?
Yes, sir.
So length of the lattice rectum is 2y, which is equal to 2b square by a. So after this, we left with numericals related to hyperbola. Let's see anything we missed. Yeah, lattice rectum we done, and we done the proof for the lattice rectum also. Then we have to do the numericals. The hyperbola numericals are little bit simple than the others. Yes, same as ellipse. They gave the hyperbola equations. They are asking us to calculate find out the foci, vertices, eccentricity, and length of the lattice rectum and of the hyperbolas. One, coordinates of the foci, vertices, and eccentricity and length of the lattice rectum. Here they are not talking about the length of the transverse axis and length of the conjugate axis also. They are not discussing much. These are the 4 points is important related to hyperbola. So based on this, we'll see the numericals in next class. A lot of disturbance from today from my side. Sorry guys. Yeah, we'll meet in next class. I will request sir to extend the class tomorrow at least for half an hour if you all are okay. Is it fine, students?
Sir, tomorrow
Yes.
I have a class.
You are having?
Another class.
No, tomorrow we are having class now. According to schedule, we are having
Yes, sir.
Math.
Like if you extend it, it will get.
before we are going to start by 5 now. Before 5, is there any class for you?
Sir, physics, sir. Before 5.
After my class?
After class, I have another one.
Okay. Then I won't extend. I will try to take one extra session.
Okay, sir.
Let's see. We'll meet in next class.
Thank you, sir.
Yeah, bye.
Thank you, sir.